Good morning. Today we are going to discuss about the non-parametric test. Earlier we have done with the parametric test, under which we have done the Z test, T test, ANOVA, and we know that under the parametric test the data should be normalized. But what would be the case when the data is not normalized? Which test which we are going to apply? For that we have a non-parametric test, under which we don't require any assumptions about the parameters or about the nature of a population. Second is, it is used when the data is not normalized. The word normalized you will came to know in the SPSS. When you are going to do with the SPSS, you will came to know what is normalized and not normalized. In simple words, we can say that when the homoscedasticity should be followed and when there are definite outliners. While doing the study, while doing the analysis, there are some outliners which we cannot remove. In that case, the non-parametric test is to be applied. It is also applied when the outcome is ordinal. You know that ordinal means the ranks or a rank. So it is also called as distribution free test. Today we are going to discuss about the first non-parametric test, that is chi-square. Under the chi-square, it can be used as a non-parametric test, under which there are two types: test of goodness of fit, second is test of independence of attributes. Under test of goodness of fit, when we are going to apply for the test of goodness of fit, in which case to check how the observed values, I am saying about the observed values of a given, are significantly different from the expected values. Here there are two terms, one is observed, another is expected values, and the symbol which is used for the chi-square is this one, under which summation of observed minus expected whole square upon observed, and here degree of freedom would be the n minus 1. Let us do one question based on a test of goodness of fit. So the question is, a die is thrown 180 times with the following results. For first time 25, second turn up 35. In this way 6 is the frequency, 6 is the number of observations, and total is 180. We have to check whether the hypothesis that die is unbiased or not. For that, firstly we are going to make that H0 null hypothesis that the die is unbiased. And to find out the expected frequency, I told you that there is only two variables, one would be the observed, another is the expected. For expected, we know that it is NP. NP stands for, N stands for total number of frequency. Here the total number of frequency is 180. 180 into 1 by 6, P. 1, 2, 3, 4, 5, 6. So P is 1 by 6. If we talk about P is 1 by 6, and if we want to calculate the Q, that is 1 minus P. That is also 1 minus 1 by 6. But in this case, we need only the P, that is 1 by 6. So in order to calculate, we get the 30. So 30 is our observed frequency. Expected frequency. So observed frequency is 25, 35, 40, 22, 32, 26. So this is a 25, 35, 40, 22, 32, 26. And expected, I have written this. So let me calculate O minus E wholes here. That comes out to be 25 minus 35, 5 plus square 25. In this way 100, 64, 416. And we have to divide with E, expected. 25 divided by 30, that comes out to be and the total found to be 7.798. We are going to put in this summation of this upon this, that is 7.798, and that is the value of chi-square. Now we have to calculate degree of freedom. How many variables are there? 1, 2, 3, 4, 5, 6. 6 minus 1 equals to 5. So at 5%, the value is given, the P value is given to be the 11.07. But our value is less. So we are going to, X value is found to be the less than the P value. So we are going to accept or reject. When I told you earlier also when the value is less than the table value, we are going to accept the null hypothesis. Accepting the null hypothesis means that the die is unbiased. So this is a thing which we have done about the test of goodness of fit. Now let us do with the test of independent of attributes. When we have to apply for the independent of attributes, for that I would like to give you an example, that is whether a new medicine is effective in controlling a fever or not. In this case, we are going to apply the test of independence of attributes, under which the two variables are independent. And how we have to calculate the expected? R into C. R stands for row total, C stands for column total upon N. N stands for number of observation. And degree of freedom to be calculated as V equals to C minus 1. C stands for column, R stands for row. Now let us do one question on this. Here, in this question, a sample of 200 persons with a particular disease was selected. Out of them, 100 was given a drug and others was not. So cured drug is 55 and no drug 65. Cured total 120. Non-cured drug 45, no drug 35, 80. This is the total. So firstly, we are going to write down the null hypothesis H0, that there is no significance between the drug giving or not drug giving. That also we can say that drug has not been effective in curing the disease. So I told you the formula is E equals to R into C upon N. So what is the total? Let me write down here. This is a row, this is a column. So this total of N row is 120, total of column is 100. So I am going to write 120 into 100 upon total is 200. That comes out to be 60, and I am only going to take care of this, that is E11. So the expected frequency I would like to write down in this manner. O, and here it is E. O 55, 45, 55, 45, and after that no drug 65, 35. The way I have calculated E11, you have to calculate it E12, E21 and E22. In this way you will get the expected, that is 60. First I am going to write this 60, then 40, then you will get 60, then you will get 40. The formula is same, that is chi² equals to summation of O minus E upon whole square. This is the formula. So we are going to calculate O minus E whole square upon E. That comes to be 55 minus 65, whole square is 25 divided by E, that is 60, 4.16, 0.625, 0.625, and total is 2.082. So it means that our chi-square value found should be 2.082. In the question, it is given that the t value, firstly let us find out degree of freedom. Under degree of freedom it is row minus 1 and column minus 1. Row are 2 minus 1, column are also 2 minus 1, that is 1. So value found out to be, and the t value, table value is, when degree of freedom is 1, I would like to write in this way, is 3.84. It is given, but our value found out to be less. So we are going to say that we are going to accept the null hypothesis and saying that drug is not effective in curing the disease. In this way, I hope you are able to understand both the terms of non-parametric test, test of goodness of fit, test of independent of attributes. In this, we are able to cover the chi-square. In the next class, we are going to the next topic of non-parametric test. Thank you.